Did you know that you can simulate a robot using SIM and Simumatik workspace? If not, this video is for you. In this video, we're going to see how you can connect Simumatik workspace with Universal Robot graphical environment, which is available for free on the internet. Using this integration, you can realize various robotic applications. So we're going to solve one exercise with pick and place of an object in Simumatik using the program which is running in a virtual machine. All right, so I will walk you through various steps which will help you to build this integration, which will help you to integrate these two environments. So the step one is you need to have a virtual machine. So I'm using a Windows environment and a virtual machine named VMware. This is the one which you can download from the internet for free. So if you open this link here, this will take you to this link of VMware Workstation Player 17. So you can download for free and install in your system. This is the step one. You have to prepare your virtual machine, and why you need that, let's see that in step two. In step two, we have to download and run URSim. So Universal Robot offer URSim, which is an offline simulator for the Universal Robots. This you can also download for free from Universal Robot website, which you can see that here. So the version which I'm using is for non-Linux because my environment is Windows, which is a non-Linux. So I'm downloading this image and launch that in my virtual machine. If you have a Linux environment, you can use this directly. So let's go back. So once you download this URSim, this is also for free. Maybe you have to sign up for an account. You have to load this in your virtual machine. So I have my VMware already downloaded and installed. I will just open that one. So this is my VMware Player 17. And once you open this, it will be like this. And then you have to download this Universal Robot image file. And once you download that, this will be located in some of your folder. And you just have to open the virtual machine from that folder. I have already done that. In this case, you can see my shortcut is here. Otherwise, if I have to open this, I can just show you where it is. Once you download the files, it will be like a packed file. So you have to extract all these files and then you will find a file here. This is what you have to load in your system. Once you do that, you will see something like this. It's like a shortcut because I'm already using this. And here you can see my file name here, 5.13. All right, this is the version I'm using. And in this virtual machine, I have assigned 4 GB RAM for this station. This you can also configure from here. If you go to Edit Virtual Machine Settings, you will see how much RAM you want to assign and how many processors you want to assign. So in this case, I'm using 4 GB RAM for this machine. I'm using 3 processors, then hard disk is 10 GB. And the important part is the network adapter. In this network adapter, you have to select NAT. This is the recommendation for this video. I'm using the option as NAT. This is used to share the host IP address. Now the host is my Windows machine. So I'm going to share the IP address from there. So once you do that, click on OK, and then you can play your virtual machine. And within few minutes or a couple of seconds, based on your system performance, you will see this Universal Robot environment system will be loaded here. All right, let's wait for that. And in the meanwhile, I will go to the next step. Next step is set up the IP address, which I just did. So you have to go to your network adapter settings, and in the NAT, I was using NAT. Now what happened when I do that? Let's go back to virtual machine. And I can maybe maximize it a little bit. So it's still loading. Now you can see that an Ubuntu environment is initialized. And you will see your environment here. Pretty simple. And now here, just to verify your IP address, what you can do that, you can go to your start icon here. And you can go to System Tools, and Xterm is just one terminal window. And you can type ifconfig. ipconfig is for the Windows, for the Linux is ifconfig. And once you press enter, you will find your IP address here. This is a little bit not too big to see, but it is 192.168.233.128. This is what you need to remember, so you can just note it down or copy or paste in a notepad whatsoever. So this IP address is important. So once you do this step, so here, this is what I explained again. You can check the IP address of your virtual machine using xterm, typing ifconfig, and that's the IP address. You have it here. All right. This IP address will help you to connect to Simumatik. The next step is step 4. Set up the IP address in Simumatik workspace. So we have already created a workspace for you, which you can use directly. Step 1 is sign into Simumatik workspace. Open the public system showcase universal robot. Select the controller and add the IP address. Connect the gateway, start the emulation. So we have 4 steps to follow. In this case, I will go to my workspace and I'm already signed into my Simumatik workspace. So you can see that my workspace is here. All I have to do is go to load and you can just search universal robot. This is already public. Just select the system and here you have some description. We have some buttons, we have conveyor, we have a robot. So let's understand this system. Okay, I will click on load. Now the system is being downloaded and it will be set up here in a fraction of seconds. Here you go, we have the system here. So here is my system and I can zoom in and visualize my system. You notice that this your robot has predefined axis here, so it is by default positioned like this. And here if you see in the end of the robot, we also have a gripper. This gripper you will not find in Universal Robot Sim Simulator, but you have to add it manually, but we have done that for you. All right, so this is my gripper, that's my robot, and you can see that this is my vacuum gripper connected to the robot, added with a constraint. Okay, so in this environment, what do we have? We have a belt conveyor running from a DC motor. We have a switch which will start the motor, and we have a sensor which will tell if the object is here or not. And then we have a box, and inside the box we have an object exit, product exit, and this is product entry. Very simple system, and we have some 3-phase supply, and here we have a robot controller. All right, if you want to learn more about the system, you can read the description in the system page. So now you have to select your UR controller and you can select that from here. And here comes the same IP address which you have in your virtual machine. Okay, this is very important. This is the IP address you can find out from ifconfig. So just put this IP address here and let me do that here. You have the IP address, frequency, you can leave everything as default. And once you do that, make sure your gateway is connected and click on play. Once you do that, and if everything is okay, you will see your robot will be in a different position. But right now I see an error. All right, let's see why is this error. Let me just disconnect my gateway, connect again. So once the gateway is running, let me start that again. And I have again an error. Let's see what is this error. So, all right, now once you see there is an error, this is because your UR3 is not started yet. So you have to start your robot software, which I can do by open it. So I'm going to use UR3. So once you start this application, this will send the access information to my universal robot, and this will make the connection. So when you receive the error, perhaps it's because UR3 is not started. So once I start this, it will take a few seconds. In the meanwhile, I can stop the emulation. So let's wait. Now this is being started. I will bring it here. It's loading. And 100%. There we go. Our application has been started. Now what I can do is I can just go back here, click on play, and now you will see robot takes the default position, and this position is sent from this virtual machine. All right. This was the step first to build the connection. So once you do that, Congratulations, you have linked your Simumatik and URSIM. Just few simple steps. All right. Now we can move the robot. We can define the waypoints, joint position, and write some programs. Okay. So let's see how this will work. Now, if I go to program the robot, and if I go to move, you will see that if I move my robot, okay, it says robot should be on first. So you can click on this power off button, turn on the robots, release the brakes, and start the robot. So this is a simulation. We have no real robots here. Click on exit, and now you can see your robot is here. I can zoom a little bit. And this is the position which is being read from virtual machine to Simumatik. Now if I move it, you can see that this is the position, the up and down position. This is a Z axis. So this you can move up and down like this. And this is your Y axis in positive and negative direction. And this is your X axis. All right, so you can move the robot quite easily in your Simumatik using your virtual machine. You can also see your axis values here. So if I move Z axis, you can see now Z axis is changing, and here for down. Similarly for your Y axis and X axis. Okay. You just need to have a little bit of basics of robotics to understand how these axes are working. And here is your TCP orientation. Okay. So let's see what we're going to do in this video. We have a tiny project. The project is we have to make a pick and place application in which the robot is going to pick the can from here, from the sensor position, and place it in the box. To do that, we need some sensor signals and the gripper signals. So at the moment you see how we are controlling the axis of the robot, we have to also deal with some digital signals, digital or analog. So in our application, we need to send the signal from the sensor to our virtual machine to execute the robot program, because we're going to write the robot program here. And then the robot program will also send the signal back here. So a couple of signals involved. So if you go to the 2D diagram here, you will notice we have a diagram already prepared for you. In this case, this is my robot controller. So robot controller has several inputs and outputs. So this robot controller is initially energized with a 3-phase supply. You can see that here. And then you have some inputs. So there are 2 inputs which are connected, and we have 1 output which is connected. So if you go to your 3D view, and here you can see that I can see robot controller, and here you can see input 0, input 1. So what is input 0? This is actually connected to a relay output. Okay, you can see DC relay. Input 1 is actually vacuum gripper signal. So what are the inputs to the controller? We have a relay output. Let's go back here. And if I go to page 2, so I have here a circuit which says a photoelectric sensor is energizing a relay, which is having its NC connected to the motor and NO connected to my controller. Okay, so what's happening basically when the sensor is turning on? So if the sensor is on, it will stop the motor and it will send a signal to my virtual machine that the object is here, which we will use to trigger the robot program. So what we do, we just start this button and we see what's happening. So you can see that now the object is here. So this will stop my conveyor. And if you see robot input, this should be having 24 volt. Let's start again. I start my program again, and let's start this one. Here you can see that 24 volt is coming here. So this is going to the robot controller. And similarly, second input is when the vacuum gripper grips the object. So it's the signal saying that, yes, I have gripped the object. Now, what should I do? So we have these 2 signals coming to our robotic environment, but we have to bridge these signals. How can you do that? To bridge these signals, we have defined first 2 signals, sensor signal going to URSIM, and grip signal going to URSIM. So these 2 signal has to go there, but how it has to go there, we have to define some variables. Similarly, URSIM will say, okay, now I'm there, grip it. So this grip command goes to Simumatik to actuate the gripper, and the access commands goes to Simumatik. Okay, so basically we have three Boolean signals: sensor, gripped, and grip. So to do that, we have to define variables. So in Simumatik, we have already defined variables starting from 64. So if you notice here, initial in register, that's the input register, starting at 64, and output register also starting at 64. So we need to define this in our virtual machine environment. To do that, you can go to here, you can go to installation, and you can go to IO setup. In IO setup, you can see here, these are the digital inputs. So if you drag down a little bit, you will find GP-Bool 64. So here I have already renamed that to sensor, which you can do that from here. We can rename the variable. This was by default GP-Boolean 64. I renamed that to sensor, and 65 I renamed that to gripper or gripped. Right? So my input, my gripper has gripped the components. So these are the two variables, Boolean variables. Similarly, in the output, I define 64 as gripper or to grip, okay? Because virtual environment will tell Simumatik to start gripping, and it will receive the signal. Object is there, so sensor signal, and I have gripped like a feedback, okay? So these variables we have defined here, and these variables you can see that this is 64 and this is 64, and how this is coming here because this is connected to our controller. So input 1 is my signal coming from the gripper, and input 0 is my relay. So this is relay is the sensor signal. This is 64 and this is 65 vacuum. This is 65 from the gripper. So this is 64 and 65, which is defined here. 64 was the sensor. And why this is relay here? Because the relay is triggered from the sensor. So this is here. And this is the gripper signal here. And when the virtual machine is telling us to grip, this you can find in the output. Here you have access. Here is the output 0. This is connected to vacuum gripper cup, which means to grip. Okay, so that's how the IOs are defined in our Simumatik environment and URSim. The next step is we have to write a program to pick the can and place it in the box. How we can do that? In this case, let's come back to our virtual environment. So here we have to write a small program. So the first thing is we have to check the variables. Okay, so here if you notice, I have already defined these variables: sensor, gripper. So what is the first step when we are simulating pick and place application? All right, now we have to do the program. In the programming, it's totally based on how you are programming a robot. Several programmers will do it in a different way, so it's totally up to you how you want to program it. In the end, the result should be the same. So in my opinion, what we will do is initially we will open the gripper. So the first part will be I will turn off my gripper. Okay, so my first step will be here I go to my empty and I set an output. And we know that we have digital output defined, which was gripper. I will send a low signal to the gripper to open my gripper or deactivate my gripper. That will be my first step. Second step is I want to move this robot to a position. Let's call it as a home position. Okay, so this position I have to define in the robot itself. So after my gripper is off, I can go back here, click on move, and this actually should be on the top. So move J to a waypoint. Now I have to select where I have to move the robot. So in this case, I will first go to set waypoint. So I need to tell robot where it has to go. So in this case, I can play around with this motion buttons here and bring the robot on top of the can. So let's move the robot now. So I will try to move it in a way that it is on top of my can. Normally when you have a real robot, you can do with the manual free drive option, but here you can also just be patient and try to bring your robot to the exact location you wanted. So I will prefer to go directly over the CAN. This is one way to position the robot. So here I can see I still need some correction in the motion. All right, I hope this will grip our CAN. So we wanted actually a home position, but if we moved here, this is just a small way to find easier your home position. So first you go to pick position, and this is, like I said, every programmer has a way to program the robot. So I prefer to first go to pick position, and I go to my program. So when you go to your pick position, click OK. So this is my waypoint 1, and what I can do is I can rename that. Let's call it pick pose. Click submit. Now, what I will do is now I will take another move command, and this pick pose, I will bring it here so I can connect that to my pick pose. And this one I need here now home position. In this case, home position will be very easy for me because I can go to set waypoint and just move the robot a little bit up here. So this is my home position, and then the pick position is just a little bit down. It's kind of like an offset. So this I will select OK. And first let me just go to cancel and change this pick pose to, so I can make a waypoint and delete this one. Can delete this one, and this waypoint is now already defined. So this is my waypoint here. Click OK, and now you can rename that to home position. I call it home pose. So now you have move J to home pose, and then it's just a linear motion. So in this case, I can make it to move L, and then it will go to my pick position. If everything works fine, we can just try to see how it works. Okay, let's take a trial. So in this case, I will just run the program, and you will see it will go down and up. So this is your home position and pick position. Everything works great. So I can stop it here. Now, once the robot is at pick position, what do we need? We need to know here, once the robot is in home position, we want to wait for the sensor signal to be able to go down. In this case, I will take an if command. So after robot is in home position, I would like to have an if command, and this maybe you can take from the advanced, go to if. So now what is the if condition? If condition means if sensor is true, which I can take from here. So if my input, which is a sensor, is true, I can click submit. So if sensor is true, what I need to do, then I need to move L. So I can bring this here. So what I can do is I can select this one, I can cut this, and I can paste it here. So if sensor is true, it will move to the pick position. And then what I need to do, I need to turn on the gripper. I need to actuate the gripper. In this case, I can go to set. So in the basic, I can go to set. What I need to set, it's a digital output. In this case, it's a gripper output. Make gripper high. This is what we made it low in the beginning. So once you make it high, you can grip the CAN, okay? So once the gripper is true, I would like to wait a few seconds. It's always better to wait. So I will wait 0.5 seconds. Once the gripper is true, then I make sure the gripper is for sure it has gripped. Anyways, we will take the feedback if the gripper has gripped the object, but I prefer to make a delay. So then comes another if statement. Now we go to another advanced and go for if. Now what we're going to read, if the gripper has gripped, because when you send the high signal to the gripper here, it goes to Simumatik, it will grip the object, and gripper sends a feedback. that we're going to read here. If input, it's gripped, submit. That's it. If it's gripped, what we want to do now. Now we want to place it in the box. So first case it will go up, but where it will go? Again, I will take move L and go to my home position. So here I can go to basic, then I go to move linearly, and here I want to go to my home position. So it will go to my home position. And once it's at home position, I want to move it now to another position to drop the workpiece. So let's find where is this another position. In this case, what I can do, I will first run this logic. So we have an idea. So let's start from the beginning. So once I go for the beginning, it will ask me to go to home position. So now I go to home position, and before that, I would like to reset the environment to check the whole logic. So now this is reset. Let's go to play. Now the robot is at home position, waiting for the workpiece, and let's start the environment. So now the environment is started, robot is at home position, and now it's waiting for the sensor. Let's trigger the object. The sensor comes, robot goes down, grip, and goes up. Oh, there is a problem in gripping. And why this happened, it's because if you look at the program, the robot is continuously executing the program. So once the gripper was on, after 5 seconds, it moves to the home position, and then it goes back here and turns off the gripper. This we should not do if we are testing the program. So in this case, I will delete this first, and I will bring that later on, okay? So I will just maybe delete this one here, and let's try the system again. So I'm gonna play from the beginning, and now we have the system running. Let's turn on the robot. Let's turn on the conveyor, and now you will see it will pick it up and goes to the top. Perfect. In this case, now I will go to pause. Now what do we need to do? We need to bring this can in this box here. So the step one is I will manually move this to this box and find out the correct position. You can go to move, and now you can move the robot. So let's move the robot. So this looks okay. So this is my drop position. So what I can do, I can go back to my program, and let's just save this position as my drop position. So I will take another move command, and let's save this set point. Okay, and call the set point drop pose. So this is my drop position, and this should be my move L command. Now, before this drop position, I need another position a little bit up, just like our home position. I will call it pre-drop position. That will be my move J, joint position move. Okay, so I can click on move. J is okay. Set point, we have to set the set point now. And I will go up. So this is this looks okay. I can go a little bit more up. Here. This is my pre-drop position. I will save this with a different name. Let's call it pre-drop pose. Okay, I have to make sure the characters I'm using is not illegal in this environment. So pre-drop pose, submit. So what is happening now? If it's gripped, it goes to home position, comes to this position, and then go down, go to drop position, and then it has to turn off the gripper. So what I can do, I can go to set, and in this case, digital output, gripper low. And why I did that in the first place is when you are starting the robot program, if the gripper command was true previously, that it will make it false. So that's why I can also copy this one and in the beginning, make gripper off again. So this program should work. Let's test the system and see our progress. So I will reset the environment and play the emulation. Now I have to start my robot program first. So play from the beginning. Let's move it to home position. and see the result. Play the robot program. Now let's see what happens. Something very strange. This is, we have to check. Okay, now one more thing you notice. Once it goes to the drop position, we will see that now. We have to do one more thing here. So let's start the system and let's parallelly see what's happening. So this looks great. Also nice, goes down, drop it. Now this position that it's coming back right from there, this is not correct. Okay, we have to go up one more time. In this case, once it's drop, it has to go up. Turn off the gripper, and then it will go to another waypoint, which is my pre-drop position. So in this case, I can just select pre-drop position. Then it will go up and then it will go back there. But here, once we noticed, what we noticed that it did not took the object away because it's not at the right location. This you can change either in Simumatik or you can change the drop position. So for the moment, I will change just the setting in Simumatik. I can just bring it a little bit here and then it should be okay. Let's try one more time. So we have the robot waiting here for the object. Let's start the system and see how it's working. So robot program needs to be started. Now it's started, pick, and going to place, drop, goes up, comes back again for the next scan. So everything looks right. If you like, you can also further on fine-tune this program based on the positioning of the robot. Otherwise, you can also extend this logic to make a sorting system based on the color of the can. So you can have another box, and based on what color it is, you can program the robot to put it in a different box. So you can be more creative in using Simumatik environment to use your robot in a different pick-and-place application. So this was the objective of today's video, how you can integrate these two systems together, write a program for pick-and-place applications, and define different positions to pick and place the object, which makes it super interesting because you are using your virtual environment for robot programming. In one hand, you're using your real robot programming, which you also use in your real robots. On the other hand, you have an environment where you can use this programming for some pick and place application using real physics. How amazing is this? So this was the objective. And I hope in the end, if you follow the tutorial, you could also program in a similar way. So go ahead, test your logic. And one more thing before I say goodbye to you in this environment, if I go to stop, if you check the system, here I open my pane, open system page, you will find some assets. This is the solution. So I have already given the solution. I have given my robot program as a solution here. If you're unable to do what was intended in this video, you can also check my solutions where I've also defined my robot positions. All right, this you can check in your asset. So go ahead, make some interesting system, and don't forget to share it on LinkedIn, and don't forget to tag us sharing your progress. Thank you for watching this video. Let's see what do we cover in the next video. Have fun. Goodbye.